Hi, welcome back. So we continue our investigation on the first kind of analysis we're going to happen, x1 and x2, when they are on the zone of being, both of them are discrete. Imagine I've got two variables expressed in the form of a gender, and this is a type of anything you can think about it. Now the gender has two possible outcomes, and when it comes to type A, B, and C, imagine it's like passing a score or something like that. Now it's obvious according to our categorization, we know this is a kind of a nominal one, and this is a kind of an ordinal one. In this case, we've got one of them is dichotomous, the other one it isn't. Now we are trying to study the bivariate relation between x1 and x2. I will assume that I have 20 subjects, okay? So I come to the first subject, gender, male, type B. And I went to the second subject, female, for example, an A, and so on and so forth. Now what happened, I do all the distribution, central tendency, and dispersion on the vector of x1 alone. And the same thing on x2. Don't forget that. Now, once you're done and everything is all right and you understand each one of them separately, we need to do the first kind of analysis on them in the form of bivariate. So to take this discrete kind of a value, we need to convert it into a kind of a table. Male and female, and x2 type of A, B, and C. Let's say, for example, I want to know, is the differentiation between genders from male to female have a different score on the type? So being a male, would you score different from being a female? If you want to flip this other way around, then your question would be concerned to ask about the type rather than the gender. I hope this side is quite clear. So I've got a 12 male here in this, and I've got 8 female in here. The 12 male, I have got their distribution in terms of A and B and C. Out of 12, there were 4 score A, 6 of them have score B, 2 of them C. Same thing for the 8 female, 2 of them A and 1 of them B and 5 of them C. Now, next thing I would do, calculate the frequency in a percentage. For example, this is 4, which compose some 20%, and those 6 is 30%, and so on and so forth. Now, it's important to see this is the sum of 4, 6, and 2, and if I want to sum their percentage, 60%, and the 60% actually, it is a 12 over 20, 40%, of course, the rest will be female. And the same thing I have done on the column-wise. 6 scoring A, which is 30% of the entire population. 7 scored B, which is 35, and the other 7 scored C, which is another 35. From this, you can make some intuition. You can speak something. 60% of my data compose male, 10% of the male happens to score C, and 30% of the male happens to score B, and etc. This is the first step. Now, what is our goal? We want to capture the relationship. Perhaps this table, we can convert it into a graphical presentation. That's exactly what I have done in the next slides in here. Now, basically what I have utilized my knowledge of constructing a bar variable. Now, I know that I have 2 genders, and I know that I have 3 different types of A and B and C. And then on the Y, I just put the percentage that represented down here. 20% have scored A, and then 30% have scored B, 10% to score C. Same thing on the female side. Just by looking at this graph, I can tell you, changing from male to female, you are more likely to score A. You're more likely to score B. That seems when you are male, you're more likely to score higher A and B rather being a female. I can maybe conclude visually there is a negative relation between female and type A and B, and negative between male and type C. So you understand this kind of relation can be explainable just only by this graph. We need to capture covariance. You need to stick to one formula, and this formula actually it is in here, and this formula basically it says, for example, if I want to capture the covariance between the gender and the type, I need basically to calculate something called the expected value of gender and type together. Then you subtract it from the multiplication or the product of the expected value of the gender alone multiplied by the expected value of the type. First of all, we need to capture something called the expected value of a gender. And what does that mean? I have 60% to be male, 40% are female. This 60%, it's coded as 1, and the 40% was coded as 2. The expected value of the gender is by taking what you coded multiplied by its distribution or total marginality in your data set, which is 60%, plus 2 multiplied by 40. Then you will get 1.4. Second thing, you want to do the same for the expected value of the type, the number 205. So I have captured two weighted value, the gender and type. Now, mathematically speaking, this value, it's the weighted value of the gender and it's a weight of the type. Next thing I want to do, I want also to capture this time a weighted value both together. Now I know 1 and 2 possible outcome for the G, 1, 2, 3 possible outcome for the T. So I need to create possible outcome for something called GT together. You need to multiply 1 times 1 is equal to 1, 1 times 2 is 2, 1 times 3 is 3, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. You will take the unique numbers among these. The possible outcome of G and T could be 1, it could be 2, it could be 3, 4, or 6. Now, what is the distribution? I know that when it is 1, it's 20%, 2, it is 30, and so on and so forth. The same thing to calculate the expected value of this new variable I have just created, come up with a new value. So now I have 3 values. Next thing I want to calculate is the variance. So how to capture the variance? By taking the square of the output. For example, here I have for the gender output could be 1. I take the square of that, 1 square, and I multiply it by its distribution percentage of 60, then plus 2 is my second possible outcome square, multiplied by its distribution of 40, and you will get this number 2.2. This is the variance, and you know how to capture the standard deviation, which is just the square root. Same thing for the T, and then we'll come up with the variance of 4.85. Take the square root, and then you get the standard deviation. To calculate the covariance between the G and the T, we need to take the expected value, GT together, which is we created this, and subtract it from the expected value of the gender alone. We did it here in the first calculation. Multiply by the expected of the type, which is the second one here. You will get minus 0.07. To calculate another value, we call it the correlation. Rho usually is calculated from the covariance. Take the value of the covariance, which is minus 0.07, divided by the multiplication of the standard deviation between both, which we captured already here. Correlation happens to be minus 0.021. Now this value is almost close to 0, but in the negative side. And actually, when I look at this, when I was moving from 1 to 2, the A value dropped from 20 to 10. The B value dropped from 30 to 5. And from the C value increased from 10 to 20. You could see this has been explained by this particular number as a covariance and this number as a correlation. Now, why is it that small? Because the sample size is 20. Now, I hope this image is quite clear to you. Now, next I'm going to introduce you to a new measures of something called the effect size. I will see you then.